So, all right. So, again, in this investigation, we're going to see how multiplication and division compare. So, I had you work on part A to start, right? And up above, you see these different sentence examples of multiplication and division, right? So, -6 times -13, is that going to be a positive or negative number? Positive, right? Because, again, when they have the same sign, we learned this rule in investigation 3.2, right? Same sign, the product is positive. So this is a positive number, all right? And who can tell me what 6 times 13 is? Robert. Not negative. 78. So this is a positive 78. Now, number 2, we have a positive times a negative. So again, what kind of answer are we going to have when we have a positive times a negative, Braden? It's going to be a negative answer. And since we already know the answer above is 78, this is negative 78. Because again, when you have different signs, which are here, positive and negative, your answer, your product is always negative. Okay? Now, number 3, some number is missing. And when you multiply -9 to that number, you get a positive number. So what kind of number has to be in that blank, Aiden? Negative, right? Because a negative times a negative is a positive. So what number times 9 is going to give you 108, Eliana? Yeah, it's 12, -12. So -12 times -9 is 108. Now again, we can rewrite this expression in a division sentence by basically, you start with the product, right, which is 108. Then you're going to divide it by one of the numbers you're multiplying. So we'll say divided by -9. And that should equal what? -12, because it's got to have every number in the sentence, right? So basically what we did is we just wrote this backwards, right? 108 divided by -9 equals -12. See how we wrote the multiplication sentence backwards? All right, so in number 4, okay, in number 4, our missing number, so we have 8 times some number gives you -48. So is this number going to be positive or negative? Positive or negative? Philip? Negative. Because again, a positive times a negative number has to be negative. So the missing number should be, Isabel? Yep, -6. Because we already said it was negative, so it was 6. Because we know 8 times 6 is 48. So 8 times -6 would have to be -48. So how can I write that sentence as a division sentence? Maria? Okay, -48 divided by 8 equals -6. You could even wrote it as -48 divided by -6 equals 8. Same thing. Because again, these two guys would multiply to get this one. All right. So in part B now, I'm going to turn you guys loose in a second to work on this. But now, this kind of looks a little familiar, right? Doesn't this look like when we did the multiplication section? But now it's division. So there's 3 groups here. So with your teammates, all right, I want you to go through and find the answers to group 1, 2, and 3. And then we're going to talk about number 2 in part B once everyone's done with that. So you're just doing number 1 in part B. You're filling in those 9 answers of what they're supposed to be. All right, so we're going to give you a few minutes. Ready? Go. All right, so what'd you come up with for group 1? Who wants to share with me the group 1 answers? Elena. Okay.
45 divided by 9, we put 5.
Okay.
And then for 21 divided by 7, we put 3.
Okay, good. And again, because remember, we can look at the other way. 4 times 3 equals 12. 5 times 9 equals 45. And 3 times 7 equals 21. All right, what about group 2, Lily? Okay. All right, good. All right, what about the last one? Group 3. Group 3. Ashley. All right, so if we decide to write an additional problem here, something different, let's come up with something. What can we write as additional problem that looks just like something that it was in group 1, but something with different numbers? Come up with an additional division problem. Because notice we have a positive number divided by a positive number equals a positive number. So I want to come up with another example other than the 3 that you see there in group 1. Aiden.
Okay.
Braden.
12 divided by 2 is 6.
Okay, 12 divided by 2 equals 6. Okay. How about one for group 2? Because in group 2 we got a positive number divided by a negative number gives us a negative number. So again, something different than any of these 3 numbers. Blake.
12 divided by negative 2 equals negative 6.
Okay, we can change that up there. Good. All right, and then what about group 3? In group 3, we got a negative number divided by a negative number equals a positive number. Robert?
Negative 16 divided by negative 8.
Okay. Good, so we got the idea. So it says write an algorithm for finding the quotients of rational numbers. Now remember, the word quotient means an answer to a division problem. So the product was an answer to a multiplication problem. A quotient is an answer to a division problem. Well, what do you notice about groups 1, 2, and 3, these division problems, compared to what we did in multiplication? What do you notice? See if you can try to dial back to the other day when we did multiplication. Lily?
I noticed in group 3 adding if you had 2 positive, it automatically, 2 negative, it stayed negative for like.
Well, not adding. I'm talking about multiplication. How do these relate to what we did with multiplication yesterday? Gavin?
For so like with multiplication, if you multiply 2 negatives to the positive, it gradually it's positive.
Okay, so they basically have the same rules as multiplication, right? And again, those rules are, all right, if the signs are the same, like in group 1 and group 3, right? Positive divided by a positive was a positive, and a negative divided by a negative was a positive. Okay? Our quotient is positive. Right? The answer is positive. And if our signs are different, like they were in group 2, right? So if the signs are different, our quotient is negative. So again, they do have the same rules. It's just a different operation, right? Multiplication to division. So remember we talked about multiplication? Let's go to the next page. So if we had 2 times 3, that was the same as saying 3 times 2, right? Because they both were 6, right? Or if we had negative 2 times 3 was the same as saying 3 times negative 2 because they were both negative 6, right? We found out that multiplication was commutative. Well, now I want you to see if I want you to find the quotients in each group and then tell me, is division commutative? Why or why not? Okay? So remember, for it to be commutative, we had to have the same number on both sides, right? And we did that when we did multiplication. Okay? Let's find out if they're the same with division. Okay? Now I know the second two work out nice, but the first two you might have some decimals. But without a calculator, just do the best you can to figure that out. All right? So with your groups, we'll give you, again, another few minutes. Let's just work on part C, number 1. All right? All right, go. All right, so when you take -2 and divide it by 3, what'd you get? It's not 1.1. The denominator is bigger than the numerator, so it should be less than 1. Yeah, it's basically -2/3. And -2/3 of the decimal is -0.6 repeating. Right? So if you're taking 2 and dividing it into 3, when you do it, if you did it like long division wise, it would have to be this. And just take 3 divided by 2 right now, right? And I can't divide 3 into 2, right? So don't you have to add some zeros? Remember when you did this? So this is 0. Well, 3 goes into 20 how many times? 6. And you keep getting 2's. So it's 0.6 repeating, right? All right. What about the other side? What happens when I flip it? What if I take 3 and divide it by -2? Blake? Yeah, because it's -3/2, which is -1.5. So is that the same number on each side? Nope. All right, so what about -12 divided by -4? Really? It's 3. Now what happens when I flip it? What do I get? When I get -4 divided by -12? Yeah, it's 0.3 repeating, or basically 1/3. Is that the same number? 16 divided by 8 is 2. And what if I do the other way around? 8 divided by 16. 0. Not 2. 5. It's a half. Isn't it 8 half of 16? Is that the same number? No. So are these commutative? No. And the reason being is because the quotients, which means what? What does the word quotient mean again? Answer for division, are not the same. On each side of the equal sign. You can't get the same answer by flip-flopping it, unlike we did up here with multiplication, right? Same answer. Same answer. None of these have the same answer. So just like when we did addition and subtraction, right? Wasn't addition commutative? But subtraction wasn't, right? Because it was its opposite. And we found out that multiplication was commutative, but the division, its opposite, is not. Okay? So we learned about the additive identity for addition, right? You basically took 0 and added it to any number to get the same number, right? So like 3 plus 0 is always 3, right? When you add 0 to anything, it doesn't change the number. Well, we have a multiplicative identity, okay, right here. And it basically means if you multiply any number times a certain number, you get the same number for A. So for example, 3 times some number gives you 3. What could that number be? If I multiply 3 times a certain number, I get 3. What would that number be? 3 times what would give me 3? 1, right? So basically, any number times 1 will give you itself. Okay? So n would have to be 1. So that number is 1. So the multiplicative identity states that any number times 1 is itself. It could be 1,000,000 times 1. The answer is a million. Okay, so it kind of serves the same thing. But 0 wouldn't work for a multiplicative identity, right? Because if I multiply any number times 0, what is it? 0. It's not itself, is it? That's why it's 1. Okay. All right. Now, it says for each rational number has an additive inverse, right? Remember when we learned addition and subtraction? When we added opposites, we always got 5 and negative 5, 7 and negative 7. When we added them together, we always got what? 0, right? So every time we added its opposite to each other, we always got 0. Remember the red chip, black chip, right? Well, we also have a multiplicative inverse, okay? So if I take an answer like 3, and I multiply some number that gives me 1, does anyone have an idea what that could be? So we make the number smaller, but we're still multiplying. Joey. No, 3 times negative 3 would be what? Negative 9. Braden, you think you know? No, it's not a negative number because a positive times a negative would be a negative, right?
That would be 0.3 repeating.
Okay, that's written as 1/3. Because think about this. If I take 3, I can write 3 as a fraction, right? 3 over 1 I can write as a fraction. And think of 1/3, right? What does 1/3 to 3 over 1 look like? What does it look like they've done there with the fraction? Huh? They flipped it, right? They flipped it. This is called a reciprocal. Just like I could take 1/3 and the reciprocal of 1/3 is? Flip it. 3 over 1 or 3, right? What would the reciprocal of 1/7 be? 7. Or 7 over 1. You see how that works? So when you hear the word multiplicative inverse, the inverse, which they call opposite, is the reciprocal. It's the fraction flipped, or the whole number flipped to a fraction. Okay, that's reciprocal. So anytime I multiply a whole number by its reciprocal or its inverse, okay, the answer is always 1. That's how we can get an identity with multiplication, is using the multiplicative inverse. Okay, so you see how kind of multiplication and addition are a little different, right? In addition, we just added its opposite. And in multiplication, we got to do a little bit more work. So take a look at this down here. We're just going to wrap this up, and we'll let you work on your homework on Monday. So if I have 5/4 times 7 over 5/4, well, there's a little rule. When I take a fraction, I'll use a different example, though. And I divide it by a fraction. You can't do that, right? You can't do that. So what they tell us in the math world is you can't do this. So what you have to do is you have to change it to its reciprocal and change the sign to multiplication. Anyone ever remember that rule? A long time ago? So you'd say 1/3, and now this becomes times. And what's the reciprocal of 1/3? This 1/3. 3 over 1, right? And when that happens, what do you get? I get 3 over 3, right? Because I multiply straight across, which is 1, right? That's the rule. So take that example. If I have 5/4 over 5/4, doesn't this part here just become 1? And we multiply it by 7 to give us 7. Using our properties of the multiplicative inverse. What about number 2? Well, you know it's about 3/5 and 5/3. Really? They're flipped around, which means they are the reciprocals of each other. So if I were to multiply these two, what would our answer be? What does the multiplicative inverse say, Gracie? Which is? What's 15 over 15? Yeah, our answer is 1. Because again, when I multiply by the reciprocals of each other, it's the multiplicative inverse, which means the answer is 1. What about number 3? Number 3, I actually have this number and this number, which are what? Reciprocals, right? And when you multiply reciprocals, you get 1. So this basically just becomes 1 times 3, which is 3. See how this works? Same thing over here. I got 1/3 divided by 1/3. But when two numbers are divided by each other, what's their answer? 1. So now I basically got 1 times 8.2, which is just 8.2. So you see how we can use these properties? All right. So it says, recall that some fractions have decimals that terminate, meaning they stop, right? At a tenths, a hundredths, a thousandths, or whatever. But other fractions go on forever. Like you guys told me before that 1/3 was 0.3 repeating, right? It goes 0.33333 on forever and ever, right? So some fractions terminate, some fractions don't. So look at 2/5. Look at 2/5. Do you think do you think the fraction will terminate or repeat? And then we have to write it as a decimal. A lot of people think it'll end. I'm going to show you a neat little trick. You can tell if a fraction will terminate if this number, the denominator, okay, can go into any base 10 number. What are the base 10 numbers? 10, 100, 1,000, and so on. Now, usually if it doesn't get into the first couple, it's not going to go into any. So think of 5. Can 5 go into 10? Yes. Absolutely. So this decimal will terminate. And does anyone know what 2/5 is as a decimal? This is a fraction. You should know what the decimal is. 0.4, right? If they ask you to write to the hundredths, you'd write 0.40, right? So 0.4. Now, let's look at 3/8. Does 8 go into 10? No. Does 8 go into 100? It's close. At 12, it's 96, right? Which leaves you 4. So it doesn't go in evenly. Does 8 go into 1,000? Well, you're saying yes because I'm pausing. Divide 8 into 1,000. Watch this. All right, 2. I'm sorry, 1, right? 8 goes into 10 one time. Leave me 20. How many times does 8 go into 20? Twice, right? Leave me 4. And then when I bring down the 4, how many times does 8 go into 40? So do we have a remainder? No. So it does go in evenly, right? So this will terminate. So 8 went into 1,000, right? The decimal for this is 0.375. What decimal place is the 5 at? Thousandths. So you can divide 8 into 1,000, and isn't that kind of strange that the decimal place goes to the thousands? 5 went into 10, right? 0.4 is in what decimal position? Tenths. See the pattern? So if something were going to 100, what would its decimal be? To what decimal position? The hundredths. Ooh, light bulbs are coming on. Now look at negative 5/6. Can 6 go into 10? No. Can 6 go into 100? No, it's like 16 point something. Can it go into 1,000? No. This won't go in anything. You can try till you're blue in the face. So this is decimal because it doesn't go into, will repeat. And it's 6.8, and I believe the 3 is repeating. So it'll be 0.833333333 forever. It never stops, which means it's a repeating decimal. All right, so attached to this, I have the summary for you, right? So let's talk about the summary real quick, and then we will send you home for the weekend. So what did we learn today? It's not the time to start talking. We only got 3 minutes. When dividing two positive numbers, our quotient is positive, right? Similar rule to multiplication when we multiplied two positive numbers, right? When we divided two negative numbers, our quotient was positive. Stop. Why are we getting up and putting things away? And then we learned if one is negative and one is positive, when we divide them, our quotient would be negative. So again, these guys right here had the same kind of rules as multiplication, right? Just talking about dividing. We learned about the multiplicative identity, which said when you multiply any number times 1, it's itself. We learned about the multiplicative inverse, which means when you multiply a number by its inverse, its reciprocal, we always get 1. Okay? And you can use these properties to help simplify expressions. Remember how we had the 0.2? Instead of multiplying all across, we were able to simplify the expression. It became really easy, wasn't it? All right? We also learned that division is not commutative, right? We proved that. Right? Division is not commutative. 6 divided by 3 is not the same as saying 3 divided by 6. We proved it with a lot of different ways, didn't we? And again, we can use division to change a fraction into a decimal. You take the numerator, divide it by the denominator to get your decimal. Okay, I even showed you the base 10 numbers, which is actually something we show 8th graders. So you got a sneak peek because you guys are so smart. All right, so I'm going to stop this right now.